Welcome to Dev Tested. We are moving chronologically, so if you haven't seen the first video, please check that out first. It sets the stage for everything we'll be learning today and for our upcoming lectures. We'll start our today's lecture with general properties of polynomial. Starting with property 1, factor theorem. It states that if a is the root of equation f of x equals to 0, then the polynomial f of x is exactly divisible by x minus a. What does this mean in simpler terms? If f of x equals to 0 and a is the root of this equation, then x minus a is the factor of f of x. Conversely also, if x minus a is the factor of f of x, then a is the root. Let's take this example. We have x to the power of 4 minus 6x squared minus 8x minus 3 equals to 0. Put x equals to 3. Then f of x would be 0. That is, 3 is the root. And x minus 3 is the factor. Going towards property 2, the fundamental theorem of algebra. It states that every equation of n degree has exactly n roots, real or imaginary, which means degree 1 has 1 root, degree 2 has 2 roots, degree 3 has 3 roots. Let's take this example. F of x equals to x squared minus 1. It has a degree of 2. So the roots would be 2. Solving it, x squared minus 1 equals to 0, x equals to plus minus 1. We have a note here. It states that if a polynomial of degree n vanishes for more than n values of x, then the polynomial must be identically 0. What does this mean? Consider we have f of x and I keep f of 1 and it comes to be 0. F of 2 is 0. F of 3 is also 0, which means f of x is 0 for every value of x. So the polynomial must look like 0x to the power of n plus 0x to the power of n minus 1 plus data dash plus 0 equals to 0. As we have learnt the two properties, property 1 and 2, let's solve this problem. Let's find the root of this equation. What if I keep f of 1? Then it is 2 into 1 cube plus 1 minus 13 plus 6, which is minus 4. And hence, the statement is not true. If I keep f of 2, then it is 2 into 2 cube plus 2 square minus 13 into 2 plus 6, which is 0. So 2 is the root. So according to property 1, x minus 2 is the factor. Let's solve it and see it. We have 2x cube plus x square minus 13x plus 6. Let's divide by x minus 2. The remainder should come 0 if x minus 2 is the factor. So we have if x is multiplied by 2x square, the first term is eliminated. 2x cube minus 4x square, changing the signs, minus and plus, we'll get 5x square minus 13x, pulling down the minus 13x. Now, if I divide by 5x, if I multiply by 5x, then I get 5x square minus 10x. Changing the sign, my 5x square would be eliminated and I'll get minus 3x, bringing down the 6. Now, if I multiply by minus 3, it would be minus 3x plus 6. Changing the signs, the remainder is 0. So we have got a simpler equation, 2x square minus 5x minus 3. Now I need to find x. Let me write down the equation first. 2x squared plus 5x minus 3. Now I need to find x. So we'll be using the basic formula, that is x equals to minus b plus minus under root b square minus 4ac by twice of a. So if I substitute this, I'll get x squared equals to minus 5 plus minus under root 25 plus 24 by 4, which is equals to minus 5 plus minus 7 by 4. And I get x equals to minus 3 and 1 by 2. So the roots of this equation are 2, minus 3 and 1 by 2. Coming to property 3, the intermediate value property. It states that if f of a and f of b have different signs, one positive, one negative, then the equation f of x equals to 0 has at least one real root between x equals to a and x equals to b. What does this mean? Consider an example. We have f of 1, which comes to b minus 2, and we have f of 3, and it is 4. So then there would be roots that lie between 1 and 3. Let's go to property 4. The property 3 was simple, right? The property 4, complex and irrational conjugate roots. It states that in an equation with real coefficients, imaginary roots occur in conjugate pairs, which means that if alpha plus psi beta is a root, then alpha minus psi beta is also a root, because imaginary roots always come in conjugate pairs. The same is for irrational roots. If a plus root b is a root, then a minus of root b is also a root. Property 5, the Descartes rule of signs. This rule helps us estimate the number of positive and negative real roots without solving the equation. What does this mean? The equation f of x equals to 0 cannot have more positive roots than the changes of sign in f of x and more negative roots than the changes of sign in f of minus x. Let's understand by taking this example. The number of sign changes here are: from plus to minus it is 1, from minus to plus it is another 1, from plus to minus it is another 1. So we have 3 sign changes. That means it has maximum 3 roots. It can be 1 positive real and 2 complex conjugate, 3 positive roots or 0 positive real roots, means 1 negative real roots or complex pairs. To find the negative roots, we have f of x, we replace x by minus x. Then it would be minus 2x to power of 7 plus x to power of 5 minus 4 to power of x minus 3. Now see the sign changes. From minus to plus it is 1. From plus to minus it is another 1. From minus to minus there's no sign change. So we have two sign changes. So the maximum negative roots would be 2. Now let's look into this note. It states that if an equation of n degree has at most p positive roots and the most q negative roots, then it follows that the equation has at least n minus p plus q imaginary roots. What does this mean? It states over here, for this equation, the degree of this equation is 7. So we have n equals to 7. We have p positive roots. So p is nothing but 3 here. We have q negative roots. So q is 2. Keeping it into the equation, that is 7 minus 3 plus 2, which is nothing 2. So this equation has 2 imaginary roots. That's a wrap up for today. Thank you. And I'll be uploading other videos in the continuation in this lecture series. So make sure your notification is on. See you next time. Happy learning.